All right, so here we are with question number 12, and we've been asked to complete the table of ordered pairs to the right for the equation, then plot the ordered pair of solutions. So, very similar to what we just looked at with question 11 and question 10, we've been given a linear equation and a series of ordered pairs, only this time the ordered pairs are in table form, just like we looked at with question 11. So we have to find the missing coordinates, whether we're finding the y coordinate or the x coordinate. Only with question 12, once we've completed our table, we then have to determine which of these four possibilities here is an accurate representation of what these 3 points would look like if we were to plot them on the rectangular coordinate plane. So let's go ahead and dive right in and solve for the first row, which corresponds to a point, an x, comma, y. So we know we are going to be working with this given equation. So y is equal to 1 over 3x plus 2. So we were given an x comma y, only this time we were given the x, we were not given the y, so let's find the corresponding y. And just like before, we'll let that bluish teal represent our x, we'll let this pink color represent our y, and dive right in to solve. So because we were given the x, we need to find the y, and to do that, we will substitute this value 0 into the equation for x and solve. So we have y is equal to 1 over 3 times x, but again, let's substitute 0 in for x plus 2. This one not too bad because we know 1 over 3 times 0, that's going to be 0, so it goes away. So we're left with just y equals, and the only thing that remains on the right-hand side here is positive 2. So when x is 0, the corresponding y value is positive 2. So let's go ahead, plug that in, and begin with our second point. So we'll erase this work here and see what we have for row 2, our second point. Well, we can see that we've been given a positive 3 for x, no y value, so it's going to be our job to find the corresponding y value. So let's go ahead and do that. Y is equal to 1 over 3 times x. So let's substitute this x value, this positive 3, into our equation, plus 2. Again, what's nice about this particular one, yes, it has a fraction, but it's not so bad because what we're multiplying by, our x value, can nicely cancel with our denominator here, right? We can say the 3 and the 3 reduce nicely. 3 goes into itself once, 3 goes into 3 once, and there we have it. So we end up with y is equal to 1 times 1, which is just 1, plus 2, and of course 1 plus 2 gives us 3. So when we are given the x value of 3, the corresponding y value is, in this case, also 3. All right, fair enough. And last but not least, let's go ahead and find the ordered pair for the third row. And we can see that with the third row, we've been given no x, but we are given the y. So let's plug in y to the equation and see what happens. So plugging in the value for y, in this case 0, is equal to 1 over 3 x plus 2. Well, just like we've looked at in previous questions now, we know that the coefficient in front of this set of parentheses is an invisible 1. So if we were to distribute this positive 1 on the outside times 0, we still end up with 0 is equal to 1 over 3 x plus 2. So we want to isolate the variable x here, and to do that we're going to first start by subtracting 2 from both sides, and when we do that we have on the left hand side 0 minus 2, and I'm going to go ahead and finish up over here. So 0 minus 2 on the left gives us a negative 2 is equal to, well, we haven't done anything with this 1 over 3x just yet. And here we can see positive 2 minus 2 is now gone. So we're left with negative 2 equals 1 over 3x. So last step that we need to take is to isolate the variable x here by getting rid of its coefficient 1 over 3. Now normally we would say, well, to separate, to undo multiplication, we would divide, right? Because this 1 over 3 is connected to this x through multiplication. So to undo multiplication, we normally divide. And you could absolutely divide both sides of this equation by 1 over 3. But remember, we've talked about dividing by a fraction is the same as multiplying by the fraction's reciprocal. And that's what I'm going to do here. Instead of dividing by 1 over 3, I'm going to multiply by the reciprocal, 3 over 1, and that is going to make the math a little easier for us, and so we don't have to worry too much about fractions. So here on the left hand side, 3 over 1 times negative 2 gives us negative 6 is equal to, and on the right hand side, again, the reason we're multiplying by the reciprocal is so that the 3's are gone, the 1's are gone, and the only thing we have remaining is that x. So we've got our variable isolated. We end up with negative 6 as the x. So when y is 0, the corresponding x is, as we just found, negative 6. So we've got our table all complete. Now it's going to be our job to determine, well, which of these 4 graphs is representative of our table of values. So what I would recommend you do is go ahead and plot just a really rough draft of what you think these ordered pairs look like on a rectangular coordinate system. So that's what I'm going to do here. And we know that the horizontal axis is x, the vertical is y. So let's go ahead and first plot this first point, 0, 2. And I'm going to let that point be represented by this teal color. So 0 for x means, remember, we always start at the origin, so the 0 means don't move left or right any. However, you are going to go up 2 units. So I'm going to approximate that to be right here. Again, this is just a rough estimate. We don't have to label each interval for our rough draft here. How about the second point? We're plotting 3, 3. So again, we start at the origin, and the 3 for the x says, all right, move 3 units over to the right. The 3 for the y says, and then move up 3 units. So we're looking something like this. And finally, last but not least, let's plot, how about negative 6, 0, and we'll use a green color. So if we're starting right at the origin, the negative 6 for x says move over to the left 6 units, and the 0 says don't go up or down any on the y, so approximately right there. So this is a rough estimate of what our graph should look like. So based on this rough draft, can we eliminate any of our choices right off the bat? Yeah, I think we can go ahead and, well, A looks pretty similar, right? We've got a point way over here on the x-axis, so do we. We've got 1 point right on the y-axis, so do we, and we've got a point just above it to the right. So that's a possibility. So I'm not going to eliminate A just yet. How about graph B, rather? Yeah, I think we can go ahead and eliminate graph B as a possibility, because notice we've got some point down here on the y-axis below 0, but we don't have anything down there on the y-axis. So I'm going to go ahead and get rid of possibility graph B. How about graph C? Well, again, we've got some point here on the x-axis, so do we. We've got a point right on the y-axis, so do we. And we've got some point just above it to the right, so do we. So I'm going to go ahead and keep C in the running and look at graph D. Here we have, well, look at this. We've got another point here on the y-axis below 0, but we certainly don't have anything on the y-axis below 0. So right away, I'm going to eliminate the possibility that graph D is our choice. So that leaves us graph A and graph C. So we've got to get a little bit more detailed about each of these graphs. So again, use the MyMathLab tools to zoom in. So I'm going to zoom in for each of our possibilities here to help us determine which of these, A or C, could possibly be our answer. So we know that although this graph is not labeled with intervals for every single dash here on our grid, we can go ahead and kind of determine which is which, right? So if here on the x-axis we start at 0, and we can see the next interval is 10, and then right in the middle between 0 and 10 we have a delineation. So what's half of 10? Well, that would be 5, wouldn't it? So we can go ahead and label this as positive 5. Can we do the same thing here? Yeah, we sure can, right? Right here is 0. We can see the next interval mark is 10. Well, that means from 0 to 10, right smack in the middle, must be positive 5. All right, how about here? Can we mark what this interval is? We have 0 right in the middle, negative 10 here on the far left, so that must mean right in the middle between 0 and negative 10 is negative 5, and the same thing is true here. We can label that as negative 5. So we can see that the interval rather for the x-axis is 5 units. How about our y-axis? Let's see if we can figure out what the interval is for y. So again, we start right in the middle at 0 on the y-axis, and the first interval that's numbered for us is 12. So let's see if we can determine how many units each of these tick marks is. So from here to here, let's see if 3 works. Well, from here to here would be 3, 6, 9, 12. Oh, must not be 12. Must be smaller than 3 as our interval. How about, let's try 2. So from here to here, if we let that be 2 units, so that would be 2, 4, 6, 8, 10, 12. Yeah, I think 2 units is going to be each interval here. So this would be 2, 4, 6, 8, 10, and then of course 12 is already labeled for us. And I think the same is true for graph C here. Each of these intervals is 2 units apart, so we will label each of these just to kind of help us. And now that we've got our intervals labeled, let's see if we can, again through identifying our points, eliminate one of these two as a possibility. Alright, so if we're looking at graph A here, this definitely to me looks like negative 6, 0, which we have, right? Here's negative 5, so this blue point here is just past negative 5, so I'm going to estimate that to be negative 6, 0, so that checks out. How about this first point here on the y-axis? Again, this to me looks like the point 0, 2, right? It's lined up horizontally with the 2. We didn't move left or right any, so that point definitely checks out. And then if we look at this next point here, this point to me, oh, well, look at it. It's lined up with the y-axis at 2. So the y component, the y coordinate for this point here is 4. But if we look at our table, do any of our points have a 4 as a possibility? No, they sure don't. So this point here has to be eliminated because it's not in our table of values. So it can't be graph A. The only graph that's remaining once we go through the process of elimination is graph C. So we'll go ahead and I'm going to make sure that's selected. There it is, graph C. And we've got question number 12 completed. Now, let me put your mind at ease and say this. My math lab allows partial credit just like I give partial credit when I'm grading a test by hand. So this question here, question 12, has really 4 different parts to it. The first row, completing this first ordered pair, is 1 part. The second row is the second part, the third row is the third part, and then of course choosing the correct graph would be the 4th part. So this question has 4 parts. So let's say that you get all of the table correct, but you inadvertently choose the wrong graph. Not a big deal. You'll still get, well, if you get 3 of the 4 parts right, that means you'll get 75% of the points possible for this one question. So I don't want you to think that just because we're doing this test on a computer doesn't mean that partial credit isn't available. It absolutely is, just like it always is for all of the tests. So if you get some of the question right, my math lab will give you credit for what you get right, and just like on a paper test, what you get wrong, you don't get credit for, right? So for question 12, here we have it, our completed table and graph C for our answer.